Welcome back. In this video, we'll be considering relationship between the gradients of perpendicular lines. Relationship between the gradients of perpendicular lines. Please do all to subscribe to Massa Tutorials. We are still on our Math 102 Analytic Geometry and Calculus. So, relationship between the gradients of perpendicular lines. So, let's go. Two lines are said to be perpendicular when the product of their gradients is -1. Two lines are said to be perpendicular when the product of their gradients is -1. So if I have m1 then times m2, the set must be equal to what? -1. So two gradients, their product, right? Their product must be what? -1. So when you multiply gradient 1 by gradient 2, you have to get the product, which is what? -1. So two lines are said to be perpendicular when the product of their gradients is -1. That is, if L1 is perpendicular to what? L2. That is, if L1 is perpendicular to L2, then M1 times N2 must be equal to what? -1. If L1 is perpendicular, so that's a symbol for perpendicular. If L1 is perpendicular to what? L2, then M1 times what? M2 must be equal to what? -1. In other words, for any two lines, L1 and L2, if the gradient of one is m, the gradient of the other is what? -1 on m. Now, in other words, again, for any two lines, L1 and L2, if the gradient of one is m, so if I have line L1 and I know the gradient of this line L1, which is m, then let's consider the gradient of another line L2. So now we know that m1 times what? m2 must be equal to -1. So we just give m1, which is what? M. That's line L1. The gradient is what? M. Right? So I want the gradient of what? M2. We want the gradient of m2. So m times m2 equals -1. Right? So we want the gradient of m2. What do? We have to divide both sides by what? M. So I have m times m2. Here must be divided on m, which is equal to -1 on m. So this one cancels. So I get m2, which must be equal to -1 on what? M. So what we are saying here is what? For any two lines, L1 and what? L2, if the gradient of one is m, the gradient of the other is what? -1 on what? M. -1 on m. So -1 on m. So that's it. So we can get the gradient of line M2, which is what? -1 on what? M. Now let's proceed to prove whether or not two lines are perpendicular. To prove whether or not two lines are perpendicular. To prove whether or not two lines are perpendicular. 1. Find the slope of each line. You have to find for the slope of each line. You have to find for the slope of each line. So let's proceed to prove whether or not two lines are perpendicular. To prove whether or not two lines are perpendicular. To prove whether or not two lines are perpendicular. To prove whether or not two lines are perpendicular. 1. Find the slope of each line. 1. Find the slope of each line. Find the slope of each line. 2. Multiply both slopes. Multiply both slopes. 3. So 3a here, we have if the product in step 2 is -1, if the product in step 2 is -1, the lines are perpendicular. The lines are perpendicular. The lines are perpendicular. The lines are perpendicular. B. If the product is not -1, if the product is not -1, the lines, if the product is not -1, the lines are not perpendicular. The lines are not perpendicular. The lines are not perpendicular. So now, to prove whether or not two lines are perpendicular, 1, find the slope of what? Each line. 2, multiply both what? Slopes. 3a. If the product in step 2 is -1, the lines are what? Perpendicular. B. If the product is not -1, the lines are not perpendicular. The lines are not perpendicular. The lines are not perpendicular. All right, let's know something here. Let's know something here. Knowing the slope or gradient of a line. Knowing the slope or gradient of a line. The slope or gradient of a line perpendicular to it is found by turning the known gradient upside what? Down, and changing its what? Sign. Again, knowing the slope or gradient of a line. The slope or gradient of a line perpendicular to it is found by what? Turning the known gradient upside what? Down, and changing its what? Sign. So if you know the gradient of a line, let's say 3, then to get the other unknown what? Gradient, we have to what? Just reciprocate what? The known gradient, which is what? 3. So when you reciprocate that, you get what? 1/3. Then you just what? Negate that, because the known gradient is +3, right? So if the known gradient is +3 and we are turning it upside down, then you get what? 1/3. And now the sign for the known gradient is positive. So what do you have to do? You have to attach negative to the what? To the reciprocal of that gradient you are finding, which is -1/3. So it means that when you multiply +3 times -1/3, the denominator or the divisor, which is 3, cancels the whole number, which is 3. So 3 cancels 3, then we get what? 1. So 1 multiplies -1, we get the product to be what? -1. Please, I believe you understand what I'm saying here. So if the known gradient, let's say again for another example, if the known gradient is -1/3, now the known gradient, we have what? The sign, which is what? Negative. So the known gradient is -1/3. Now, if you want to find for the other gradient, which is the unknown, you have to what? Reciprocate what? The -1/3. Now, when you reciprocate -1/3, we get what? Positive what? We get -3. Since the known gradient has what? Negative already, we don't bring what? The other negative again. We don't bring the negative for the what? For the unknown gradient. So -1/3 times what? Positive what? 3. Then we get that. So the unknown gradient is now what? +3. So when you multiply -1/3 times +3, you all get what? -1. I believe you are getting it. All right. So that's what we are saying what? Here. That's what we are seeing here. So now, let's start with examples here. Let's start with examples here. So we have examples. Write down the gradient of lines perpendicular to the lines of gradient. So they are saying we should write down. This one is very simple. Write down the gradient which is m of lines perpendicular to the lines of gradients. We have 3 1/4. We have next 6. We have and neg 2 on 3 respectively. So we assume that this is L1, L2, L3, L4. They all have what? Different gradients. So gradient 3 1/4, neg 6, so neg 2 on 3, 2/3, right? So now they said if these lines are perpendicular towards another line, right? So write down the gradient of the other what? Unknown what? Gradient. How will you get the unknown gradient? So let's see. So we all have to use the concept which is m1 times m2, which must be equal to what? -1. So we know the gradient. So we assume that m1 must be equal to what? +3, right? Then we insert or we substitute inside. So we have 3 times m2, which must be equal to -1. Then what do we have to do? We have 3 times m2. We divide here by what? 3. Then here also by what? 3. So we get m2, which is what? -1 on 3. So we have that. Which is m2 equals what? -1 on 3. m2 equals what? -1 on 3. So this is the unknown gradient, and now it is known. So that's it. Now 1/4. We have m1 times m2, which must be equal to -1. So m1 is 1/4, then times m2, which is equal to -1. So how many times here? 1 then 2. We multiply through by the divisor or the LCM, which is 4. So here we have times 4, then times 4. So I have m2, which must be what? -4. So that's the unknown gradient. Then here we have m1 times m2, which is equal to -1. So I have m1, which is what? -6 times m2, which is equal to -1. So I divide here by -6 next. Since this one cancels, so I have m2, which is equal to 1/7. Right. So last one, which is -2 on 3 times m2, which must be equal to -1. So we just multiply here by 3, also by 3. So we have this one cancel. -2 times m2, which must be equal to -1 times 3. I can divide here by -2. This one cancels. So I have m2, which is equal to 3 on 2. So that's the m2. That's m2. Kindly watch it carefully. Alright, so let's move on to the next example. We are moving on to the next example. It says, show that the two lines, so example 2, show that the two lines 3x plus 5y minus 8 equals 0, and 5x minus 3y minus 11 equals 0 are perpendicular. So how best can we solve that? So show that the two lines 3x plus 5y minus 8 equals 0 and 5x minus 3y minus 11 equals 0 are perpendicular. So how best can we solve this? How best can we solve this? So now we have to note that m1 times m2 must give us what? -1. That's the most important thing when solving for perpendicular lines. So show that the two lines 3x plus 5y minus 8 equals 0. So let's start 3x plus 5y minus 8 equals 0. So we have to express it in what? In the slope equation form, which is y equals mx plus c. So we have to make y the subject in L1, which is line L1 here. So I have 5y, which must be equal to -3x plus 8. Then what do we have to do? We divide here by 5, here also by 5, here also by 5. So I have y, which is equal to -3 on 5, x plus 8 on 5. So we can say that m1 here is -3 on what? 5. That's the coefficient of x, is the gradient for that line. Then now here, the next line, which is 5x minus 3y minus 11 equals 0. So we have to make y the subject. So I have -3y, which is equal to -5x plus 11. So we divide here by -3, -3. So I have y, which must be equal to 5 on 3x minus 11 on 3. So we can say that m2 must be equal to 5 on 3. Right. So now let's see. We have m1, which is -3 on 5, m2, which is +5 on 3. Let's multiply their two gradients and see whether we get -1. If we get -1, then that means the two lines are perpendicular. If we don't get -1, then that means the two lines are not perpendicular. So if you want to check, do further checks here. -3 on 5 times 5 on 3. Let's see whether we get -1. This one cancels, so we have -1 times 1, which is -1. So we can conclude that since m1 times m2 gives -1, we conclude that the two lines are what? Perpendicular. So can you watch it carefully? Last example, then I give you some to go and try. If you have any problem, if you have any grievances, please kindly contact the following line. That's Massa. I'll pick the call and we talk. Alright. So 05410-86489. 05410-86489. So that's an MTN number. Alright, so we move to our last example. It says given point A, -1, -1. We are given point A, -1, -1. Then point B, 0,4. Point B, 0,4. Then point P, we have -4,3. We have -4,3. Then point Q, it gives us 6,1. So they said we should what? Determine whether or not AB is perpendicular to what? PQ. Determine whether or not line AB is perpendicular to what? Line PQ. So how can we determine whether or not line AB is perpendicular to what? Line PQ. So it says determine whether or not line AB is perpendicular to what? Line PQ. So now let's start. Solution. We have to first find for what? The gradient of what? Line AB. So the gradient of line AB the gradient of line AB, which is y2 minus y1 all on x2 minus x1. So now we have x1 y1, x2 y2. y2 gives 4 minus y1, which is negative 1, all on x2, which is 0 minus x1, which is negative 1. So I have m of AB, which must be equal to 4 plus 1 all on 0 plus 1, which is 5 on 1, which gives us 5. So we know that the gradient of AB is what? 5. Now let's see the gradient of PQ. The gradient of PQ, we have our formula, which is y2 minus y1 all on x2 minus x1. So I have x1 y1, then x2 y2. So y2, which gives 1 minus y1, which is 3, all on x2, which is 6, minus x1, which is negative 4, right? So I have here to go negative 2, all on 6 plus 4, which is 10. So here, I get what? The gradient of PQ, which is negative 1 on 5. So now let's check. You have to do further checks. M1 times M2, or we can say that the gradient of AB times the gradient of what? PQ must be equal to what? Negative 1, right? So now 5 times negative 1 on 5. This one cancels. So I can get what? 1 times negative 1, which is negative 1. So since the gradient of AB times the gradient of PQ equals negative 1, then we conclude that indeed line AB is perpendicular to what? Line PQ. So kindly watch it carefully. Alright, so try these homeland questions for me. Try these homeland questions for me. So for each of the following, determine whether line AB and line PQ are what? Parallel, perpendicular, or neither. So if they are not, then you conclude that they are neither what? Parallel nor what? Perpendicular. So we have one, we have point A 2 3, point B 5 6, point P like 1 4, point Q 5 10. So we have this, then 2, point A 1 2, point B 4 5, point P like 4 like 1, point Q like 10 5. Then 3, we have point A like 2 3, point B 3 like 3, point P 4 2, point Q like 2 like 3. So kindly write it faster. Alright, thank you for subscribing to Massa Tutorials and thanks for watching. Until then, bye bye.